Welcome to this episode of the MLSecOps Podcast. We have a guest here with Adrian Wood, the writer of the OffSec ML Playbook. Hosting this event is going to be me, Dan McInerney, the threat researcher at Protect AI, and Marcello Salvati,
hello everyone,
threat researcher at Protect AI. And Adrian, if you'd like to give yourself a little introduction.
G'day, it's nice to meet you both and to be here. I'm Adrian Wood. Some people call me Threllfall. I work on the Red Team at Dropbox. Prior to that, I was a engineer at Wells Fargo, and before that, I worked for 8 years as a founder and lead engineer at a company in Australia called Whitehack, doing primarily red team assessments.
Cool.
Nice.
So, as our guest today, I think one of the things we wanted to talk about was a really cool project that you did where it's called the wiki.offsec Playbook. So can you explain a little bit about what this is and who the audience is for?
Yeah, so the OffSec Playbook is designed primarily with red team operators in mind. Folks like myself who sometimes find themselves in a position on a network with access to a thing, and you want to know what to do next. But in the case of machine learning pipelines, sometimes that's not super obvious. And there's a number of reasons for that, right? Such as adversarial ML, and the world of adversarial ML is full of a lot of academic papers, some of which have code, some of which do not. Many use words that red team operators use, but they mean a different thing. And I'm just trying to deal with that problem first and foremost.
Right.
Yeah.
There's so much. There's academic papers. I think we've spoken about this before. They drive me insane.
Yeah. The definition of red teaming in itself is kind of now all over the place between, there's a big difference between what we would consider a red team and what an academic paper would consider an AI red team.
A lot of times in the security world, we're we'd like to red team something. That means, I get to pick locks, I get to break in, I get to phish them and stuff. And then these academic papers are I red teamed the model. I'm thinking, I don't think I picked a lock to get into this model.
Yeah, which is funny because, it's sort of a joke in the industry where it's prior to this, the definition of a red team changed between consultancy companies and have each person in each company has its own definition. Now it's even... The waters are even muddier. Yeah. So it's
and I love this.
Very interesting.
I love this playbook because it does take a lot of these academic papers and concepts that should have just been a blog post and a GitHub release.
Yeah.
Instead of 17 pages of dense academic stuff. So it's really nice to see this kind of condensed down.
Yeah, especially from a practical standpoint. That's because I haven't done red team in a couple of years at this point, but if from a practical standpoint, this is really awesome.
Yeah. So why'd you kick this off? I mean, what inspired you to make this to begin with?
So I've been doing ML things whilst red teaming or doing other things in that sphere for probably more than 8 years now. But last year I went to a conference called CAMLIS in DC, the Conference for Applied Machine Learning in Information Security, which is an amazing conference. If you ever get a chance to go buy a ticket right now. It's in October. I hope to see you there. And I sat there for 2 days listening to all of these presentations from people in industry and academia, releasing applied practical things for InfoSec. But I think across the 2 days, there was only one talk that was an offensive use case of machine learning. The rest of it was for hunting hackers, finding bad people, and I was just that's interesting. And I sort of sat there feeling there was this big wave of machine learning come down on red teamers that are kind of for the most part doing the same thing they've been doing, right?
What was that? What year was this?
Last year.
Last year, okay.
2023. Yeah.
Yeah.
And so. Sitting there, I'm feeling kind of overwhelmed. And then I started thinking about the way that my colleagues were talking about success in operations and how that had changed from, say, 2018 until now. Back in 2018, you'd hear a lot of red teamers say things like, I got in and out, totally clean, hit all the objectives, no worries. And more recently, I was hearing things, even from the same people working at the same companies, you know, their familiarization with the organization that they work for has gone up, but they're getting caught more than they used to be, which is usually the opposite of what happens. And it was coming down to basically like the mean time to detection was falling very quickly. And they were often being caught by machine learning. So I was like, we got to use more machine learning adversarially, offensively. We got to get more people tooled up in this space. So that's kind of how it got started.
What was your machine learning background? Because you said you were like dabbling in the machine learning world before you were even doing the security stuff.
Oh, yeah, so it was more dabbling in machine learning in security. So working with like trying to do behavioral analysis in, say, like supply chain security in particular was one of the earlier projects that I did. Trying to uncover anomalous commits in public Git repos of things that I cared about. I applied similar logic with sentiment analysis to detect trading bots trying to force swings in the crypto market and things like that as well, just as like a side hobby. And then more recently, I've been doing like anomaly detection of EDRs. So benchmarking an EDR's behavior on a system using, say, just even simple unsupervised learning to see what system calls it's making, to identify like any changes in network traffic, so that when you're in the middle of an op doing things, you've kind of got this like little canary in the coal mine that tells you when the EDR's like woken up and has started to care. Just as a way to sort of know when things are not going so great.
So I'm a big ML nerd. What were some of the models you used, just as a sidetrack here?
Yeah. So I was, for sentiment analysis, I was doing a lot with an open source project called Veda, which at the time was like state of the art for sentiment analysis, because it could it had some understanding of like emojis and their meaning in like current culture back in the day. And that was the benchmark that I was using for that. And then for like bot detection, I actually can't remember the name of the project, but it was like another Git repo thing. You know, I find generally as you can kind of tell from the playbook, is I glue a lot of stuff together.
You're speaking my language.
My
whole career.
Yeah.
Oh, I like this tool and I like this tool. Let's just make these two tools work together asynchronously in Python.
Yeah, I feel like that's the story of most offensive tooling anyway. It's just like, hey, I just glued the stuff together just to get it working.
Now it works in one command instead of seven.
Yeah, because normally you need a thing and you need it right now.
Yeah, exactly. Like,
so
it's on the job tooling is pretty much where like most of the stuff is made for sure. It's funny they mention that, because I feel like the defenders, to an extent, in like defensive products to that point, have been using at least forms of ML for quite a while, I feel like, in a lot of products, and the offensive community has actually been slow to sort of catch up on this,
right,
to an extent, and which I kind of feel like is sort of a trend. I think I feel like things go in waves in the offensive community. I feel like
I feel like it's like the more you see it on the engagements, the more familiar you are. So like, you know, I don't know anything about mainframes, and yet when we go do bank jobs and stuff, there's oftentimes a lot of mainframes there, and suddenly you become a mainframe expert because of that 2-week engagement. And I think that's where we're at now, is people are starting to see these web applications and tools on their engagements, and they're like, what does this do? Oh, it's ML.
I guess what I was referring to, it's like, because it's not something, because like it's been around for a while in like EDRs and a bunch of like network analysis tools, I guess, right? Like there's a bunch of products, like not you can censor this out later, but like not to plug this company, but I know for a fact like Darktrace and a bunch of like all of these like products use this kind of stuff. So I guess it's like not in your face. It's not like, hey, this is like an ML thing. So I guess people haven't really like dug deep into it in the offensive community. But yeah, to your point, like the minute you start seeing like ML flow or H2O, you know, relying around on engagements and networks, like you tend to pick up. Like I feel like at that point, like you pick up on it real fast.
I think ML also has a image problem within the offensive security space too, I think, because there were many companies that were very early adopters of ML for security, probably oversold the capabilities of the projects in their early days.
Oh, for sure.
And those things, when they faced real world encounters with red teamers and others, just kind of didn't do so great. And I think a lot of people formed a lot of quite firm opinions at that point about the efficacy of
100%.
ML,
Oh, yeah.
that they
100%.
now need to walk back, and they need to walk it back like last year or earlier.
Yeah,
right?
correct. Yeah. There was definitely, yeah, go ahead.
We see that a lot with LLMs too. Like LLMs first came out, and people were like, well, it doesn't even do basic math. And then, the next generation gets a little, quite a bit better at it.
Yeah.
And suddenly people are like, oh, okay, well, maybe this isn't as bad as I thought. I feel like everything has to be black and white when you first see it. And there's just so much gray area.
Yeah, there's a lot of opinions that don't, like, they change very slowly over time. Like, they don't like it. Sometimes we, as the defensive community, I feel like doesn't like to face the facts that, things have changed and things have changed. But yeah, so like, can you dive into a bit like each category in your OffSec ML playbook in tool in wiki here, just to give us an idea?
Yeah.
Yep. The adversarial category right now is primarily looking at things to do with LLMs, but I'm adding more things all the time there. And what we're talking about there is attacks against ML systems. And that category is broken down basically by the level of access that you have to perform that attack, whether that's API access or, like direct model access and so on. And I've noticed that people are starting to use this in threat modeling too, this category, because a team will come to them and say, hey, we want to stick embeddings in this location for like LLM RAG systems. Is that okay? And people will say like, sure, because they don't realize that like embeddings can be fully reversed basically back to text, but with a project from a guy called Jack Morris, I believe. It's called like vector text, right? Like, so you can use the category to basically either attack something or figure out how someone could attack it for those purposes. The next category is offensive ML, which is where we're talking about using ML or leveraging ML to attack something else. So that could be, as an example, there's a great project in there, one of my favorites by Biagio Monterulli, which is a phishing web page generator. So it deploys a local phishing web page detection model and then generates HTML attributes into your phishing web page until the phishing confidence goes close to zero, and then you use that version. And I'm getting feedback from people all over the world that are using that project that Biagio made and saying like, it works, it's good. I use it myself, it works, it's good. Same thing goes for say like droppers, using a dropper an ML-enabled dropper to make decisions about whether to drop, right? Because you don't want to drop into a sandbox. Supply chain attacks, that's got a lot of stuff in there from both of you, actually, from Protect AI.
Let's go. Pat ourselves.
Yeah, there you go. So using the ML supply chain, you mentioned things before like H2O, Flow, ML Flow, all those things are in there, but also ways of using the models to attack ML pipelines and more, as well as database attacks and so on. I figured I better add a defensive category at that point because I was like, this site's just getting a little rude. So I've added a defensive category. It's a work in progress, and mostly because I don't like adding things to the site that I haven't personally used. So there can be a bit of a backlog there while I like get around to seeing, is this thing worth a damn, basically. And the defensive system is tracking a lot of benchmarks, which I'm very interested in benchmarks, especially of LLMs, and a lot of other use cases like tools for putting the data inside a binary into an ML ready state. There's a project called Bin to ML by a guy called Josh Collier in the UK, which is an amazing tool if you're trying to build out like malware data sets and things. So that's sort of how all of that's coming together.
Yeah, I see LLMs as being really, really, really good at taking huge amounts of data and then distilling it down to a reproducible form, like a JSON file or something. Yeah. And I feel like log analysis is just one of the best places ever for LLMs to start doing this work. But I think there's a lot of room still that for predictive machine learning or traditional machine learning, where I think people kind of forget. Once LLMs came around, they're like, well, forget about XGBoost and PyTorch and neural networks and stuff because we'll just use an LLM for everything. But I think that's a mistake right now. I think for right now, things like log analysis, I suspect predictive ML might be a little bit better at analyzing those logs than an LLM.
I can see that.
There is a great contribution made recently by Dr. X, she's based in Charleston, South Carolina, and she's added a benchmark comparing for log analysis of network traffic, traditional predictive ML versus LLMs on the same data sets.
Really?
Which is not something that you see done often enough in a benchmark.
No,
It's
you don't.
Should I use this or should I use that? I'm like, this is great. Like, this is my new favorite benchmark. So thank you, Dr. X. Which has also been contributing heavily.
What was the conclusion?
That traditional ML was still significantly better at like network traffic log
That's what I
analysis.
expected.
Makes sense. Yeah. Yeah. I mean, I think like right now, like we're just hammers and everything to us is nails right now with LLMs. Like it's this new shiny thing and we're just trying to apply it a little bit everywhere. So, but yeah, I mean, it makes perfect sense that like traditional ML would be like a lot more better at this.
And it's like I to defend that position, I do feel like LLMs will overtake predictive ML in almost all realms within a couple years. But right now, I think people are they're sleeping on, just using traditional PyTorch and the traditional predictive MLs for use cases that they're really good at. Yeah. They're much better at those narrow use cases for finding anomalies and that kind of thing than LLMs are.
There's a lower barrier to entry, though, with LLMs, which is partially why I think everybody's just, like, trying to, I can use LLMs here, there, everywhere.
And so, as advice from someone who's done a lot of predictive ML stuff, the auto ML tools that are out there right now are really, really good. So if you're using an LLM and your LLM's just not performing for your PCAP analysis, for your log analysis, go check out some of the auto ML stuff like AutoGluon, H2O, Vertex AI, Azure AI. Like, you literally just upload your data set and it just does everything for you and spits out a really good model.
No. What is your what do you in terms of like defensive capabilities, like what do you think are like some of the best open source projects that you've come across that like are really good with doing traffic analysis or malware detection or anything along those lines?
Yeah, the malware detection stuff in defensive open source models is something I've been diving into a lot recently, using Ember and Sorrel, which are starting to get a little long in the tooth, but people have stopped releasing like models that fulfill those capabilities for probably very good reason. But those are really great defensive tools to help you sort of get an understanding of how things like EDRs and even VirusTotal to a degree is making decisions about files. Because apart from it being like good to help you run detections, a problem that we run up against a lot when it comes to incident response is we have these black box tools that find problems and they find them on a Friday night when there's no one to talk to, and then you've kind of got to figure out why is it mad about this file and can I go to bed or not?
Right.
Mm-hmm.
But they don't give you any information because they're scared that someone's going to flip the model around on them. So you get these like hyper generic statements like advanced ML detection on this file, but no reason given, even if it was a Yara rule, you get like little tidbits that tell you like, oh, okay, it's mad about an LD preload or it's mad about XY.
Sounds like a Bill
These
Gates
ML
error
systems,
message.
you get nothing, right? So I like these defensive models for a few reasons, is that they kind of like, I lean on a lot of the properties of transferability in these systems to help me sort of like figure out why are these other black box systems mad? And you can do this for defensive purposes and offensive purposes.
That's a really
obviously.
good idea. Yeah. It just saves a lot of time without using like anything super advanced either.
Yeah, I think one of the, like, you brought up a good point where it's like, I think a lot of Like, I think one of the biggest issues with doing this kind of stuff is like what you said, like the models can sort of be flipped around on them because like you can potentially use that to like evade like all of the detect. Like if there's something that if there's like an endpoint that you can hit that just gives you, hey, this is bad or good, like you can use that to evade stuff too. So it's like it's another
Like the whitelist,
dual use.
blacklist.
Yeah, it's the whole dual use thing again. And I feel like with ML particularly, it might be like almost like a different realm because like it's a lot more powerful than like traditional. It's like both for offense and defense. It's a lot more powerful. So it would definitely be interesting. I think.
Yeah.
Let's see how we're gonna handle that, like both defensive and offensively.
So you do a lot of work with model files now, and I feel like this is very underrepresented.
Yeah.
I saw that you did a talk at Black Hat Asia on like model artifacts and things. And here's something that I think our audience probably knows at this point, but I don't think the broader audience understands is that models can run code. They're essentially viruses.
No.
So what was like the main point of the talk that you gave at Black Hat Asia?
Yeah, so I think the main point number one was that models for the most part are full-blown programs, and that's bad, as you said. The second component of our main takeaway was the type of access you give an attacker when they use models as a malware vector is crazy good.
Yep.
Like it'll be one of the shortest assessments you've ever run to get into crown jewel data if you use model-based malware. And in general, a lot of tooling that we can stick in a pipeline to make automated decisions about incoming files or even sandboxing during IR is like not super ready for model malware.
Yeah, I found that too.
Yeah.
Did a search on like antiviruses, put the really obvious payload in a whole bunch of model files, and none of the antiviruses caught the base 64 encoded Python exploit.
Yeah, it was like Meterpreter, right, or something. Just basic
Just
reverse
the most-
Meterpreter shell or something.
It was just a reverse shell. It was
Yeah.
ridiculous. It's like, this seems really obvious,
No.
but they don't find it.
Yeah. When you dig into it, as a lot of the time is like they're not even capable of like looking at the file type at all, full stop. So you sort of, a lot of them are like not even getting off the ground. Then you've got other issues like the file size is a massive complicator of doing an AV check or sandboxing a thing, you know, because an old school technique is just make your malware really, really big.
Yeah.
Well, like the models are just big by default, and it's not even weird.
Yeah. Yeah, I remember there were multiple times where I just like on purpose created like really, really big like malware payloads, and like the like AVs just don't scan it because they don't want to affect performance of the end user, which is wild.
You said that there was really, really huge access when you get access to when you use a model-based attack. Like, why?
So, as I understand it, and so I did this attack in a red team op, but also in bug bounties, because I wanted to know, like, can I make a generic statement here? Turns out I can. And that generic statement is that at most companies, you see that ML engineers have to work a little differently to everyone else. In their development environments, they need production data to do their job. So they can often supplement with synthetic data or like fake data that is meant to look like real data. But at the end of the day, for some tasks, they just need the real deal. So they need that in special development environments that exist inside your business in like the ML pipeline. And what that means is that these ML pipelines have direct access through, say, like a S3 store or some sort of API call to something like Snowflake or Elastic or whatever, and they just have access to the crown jewel data because it's by necessity. So when an attacker gets in this environment and has like a shell in this environment, has, you know, like remote administration type access to this environment, they can just use all the tools for their intended purposes to carry out an attack. So they just look like another ML engineer in the pipeline doing things. And there's, you know, given that it's kind of treated like a development environment, you see a lot of like standards have are not the same as you may expect in other elements of a production environment, even at like quite mature companies.
Yeah, it's just like a living off the land sort of technique applied to ML, which, yeah, I mean, that kind of makes sense
Yeah.
for sure.
Yeah, because I
Yeah.
mean, especially since the
And-
ML engineers, they need to use the cutting edge tools, and the cutting edge tools often are cutting edge because they
Or
save
experimental.
time.
Or experimental.
They're experimental.
And,
And they save time on security testing and stuff.
Yeah.
And it's like, well, no, like my manager needs me to get this project done. I need you to let me install, Triton or something and expose it to our colleagues over in, Georgia or whatever.
Yeah, whatever. Yeah, exactly.
Yeah, I found the exact same thing to be true, that people give ML engineers. There's actually a really good talk by Will from SpecterOps on iHunt's sysadmins. It's like many years ago. And that was like a real turning point for hackers to start using PowerShell and living off the land and those kind of things.
Yeah, that's true. Yeah.
And that's because he attacked sysadmins. And sysadmins essentially have almost less power than the ML engineers today. Because the sysadmins might not have access to all the databases or whatever, but the ML engineers, they need access to all of these databases and all of those data sets, and they have to put them in one place. It has to be one data set that you feed to this model.
Yeah, and there's a direct monetary value tied to all
Correct.
of that, which is a little bit different from sysadmins, where it's like, yeah, I mean, sure.
That's a
like,
good point.
You
That's a really good point.
You get credentials. You can ransomware the stuff. Yeah, sure. I mean, yeah, okay, but we're not talking about like millions of dollars worth of like compute time to actually train models or like engineer time to clean data and stuff.
Yeah,
and all the
like, I think
ETL pipelines. And
We're getting to
stuff,
the point where these models are going to cost $1 billion to train. At the highest end foundational models are going to be $1 billion. If they're not already, I think they might already be $1 billion.
Yeah,
If not more.
well, I mean, yeah, 100%.
Crazy.
Yeah. So that's definitely interesting.
Another aspect of all of these kinds of attacks in ML pipelines that encouraged me to make the playbook was, a lot of adversarial ML tools, even if some of them even call themselves a post-exploitation toolkit or whatever, try and run one through your C2 implant, see how you get on, right? Like the playbook is also an amalgam of things that I find work through C2 implants, because there are a lot of limitations to using, say, a lot of interactive type tooling via a C2 implant, especially on Linux, where like things just break a lot. And it's difficult to go, if you have a Linux shell, it's very hard to go interactive again within one. It can be quite flaky. It's one of the riskier things that you'll do. So sort of like finding the things like that actually just kind of work and won't burn the amazing new access you just found is really important.
Yeah. Yeah, that's true, because like most of the like C2 tooling or just red team capabilities are geared towards Windows environments. So like, yeah, 100%. Like there's definitely, like, that's my experience too, especially like Cobalt Strike and stuff. Like it's a lot less mature for Linux than it is like for all the post-exploitation capabilities. That's another area too, which is going to be interesting, like to see how that evolves. Like I think right now the red teaming community is a little bit averse to like LLMs and C2s just because of the whole like data retention problem and like the client's data and all that. Well, at least in the consulting field. I mean, if you're an internal red team, maybe you don't really have to care that much, but like it'll be interesting to see how that evolves too. I feel like not a lot of people are exploring the potential of like LLMs and C2s right now, which is something that I've been thinking about a lot, but it'll be very interesting to see like what you can do with that.
Yeah,
and
I
scary
have so
too.
many words to say about that.
Please
same.
go on.
Yeah. Like same. Yeah, this has been. Yeah. Go on. Like give it. Yeah,
Okay.
please feel free.
All right. So if we sort of just go back to some sort of like start with some sort of like philosophical basis, back to the original part of the conversation, I think that might be helpful. Is that we spoke about a blue team wave of ML, right? We're talking about a flywheel spinning with a lot of energy, a lot of momentum, right? And it's gaining speed all the time. Why? Because blue team tooling is getting telemetry constantly from all the customer environments, not just about bad things, but more importantly about good things, about normal things, which is like a recurring problem in like InfoSec design of launching a new product, as I understand it, is just having a good benchmark of benign data is not something you see very commonly. People like to release malware data sets, not like a data set of nothing.
Yeah.
Here's some numbers.
Yeah.
Yes. If we extrapolate that problem then to red team ML, you mentioned about like red teams, especially consulting red team MLs, have a heck of a time putting together red team data sets to steer LLMs or to steer any kind of ML hackbots. Because what does most red teams do at the end of any engagement? Like, what are they typically told to do? It's like delete everything, keep nothing, burn all your telemetry down. Like, and if you do work somewhere a little bit more, you know, forward thinking or whatever it might be, that can keep some of that. Now you've got the problem, you've got to clean this data somehow so that you can keep the good telemetry but none of the customer information, and it is just quite a headache. But if you can tackle that particular problem of red team telemetry, red team data with something like there's been a project released recently which I think philosophically kind of fills this space, at least for my needs, called Nemesis, which is a SpectreOps project actually by Will and co. And it's sort of like working on this idea that, you know, if you want to build a good hackbot, you need good telemetry. So you have to keep it, you have to save it, you have to nurture it if you want to get anywhere. And you can really only beat ML with more with your own ML, because it's the only way you're going to understand.
Terminator.
Yeah. But the advantages, philosophically speaking, are that a red team flywheel is always going to be smaller than a blue team flywheel. Small flywheels change axes quickly. They can navigate a complex landscape more quickly. So, you know, there's still going to, that asynchronous nature of attack and defense is still going to exist in the ML future, but only for those who nurture their offensive data, basically.
Yeah, that's a very interesting problem, because like I honestly don't like, there's might be like 2 to 3 consultancies in the world that potentially have the bandwidth to actually do that, in my opinion. Like, because a lot of, especially boutique firm, because the problem is like really good red teaming firms or red teamers generally work at like boutique consultancies where it's like 5 people, and like you're not gonna have a lot of bandwidth to like do like actual, like, you know, get income, and at the same time like actually be that forward thinking where you have to have like a whole ETL and anonymization pipeline for all your customer data.
Yeah. So was there anything that you missed that you wanted to talk about that we didn't get a chance to discuss yet?
Yeah, I suppose we could talk a little bit about agentic LLM stuff if you wanted to, or maybe we could talk about things in the threat landscape, like what you're seeing out there in terms of the activities of whoever you want to talk about.
The agentic LLMs, I think, are about to just shift the entire economy, I think, in the coming years. So what do you know, and what interesting tidbits have you explored with the agentic LLMs?
I've looked at a lot of the LLM hackbots and regular hackbots over the years, and generally, like, they're kind of tricky to use because as an operator, most of the time that I am looking to use something like that, it's on a box that has a whole bunch of like enterprise security on it. So you only get so many, call them requests, that you can make from say like shell access before, you know, you've blown it up, which makes using a hackbot like in that capacity that I think people were envisioning a little hard. They do kind of work okay as sort of a web app security tool because you don't really get punished for making 1,000 requests to a website. But I would stress that people keep very soft opinions on these kinds of things because, like, the hackbots of last year to the hackbots of now are quite different.
100%. 100%.
There's even one that came out this week that is, I haven't tried it yet, but I'm sort of waiting for some of the dust to settle around that, but it looks quite appealing. I think it's from Cornell University researchers, I want to say.
Was this the vulnerability discoverer?
Yeah. Have you looked at that one?
Yeah. I read this paper. So I've explored this topic quite a bit, and so has Marcello. Yeah. you can essentially create a corporation out of LLM agents. You've got one that hunts XSS, one that hunts SQL injection, and you've got a manager, and they just tell them, hey, look at all this code base or look at this web application, and just focus on your specialty. And through this few shot prompt engineering examples with React and Chain of Thought and Tree of Thought, you can really get surprising accuracy in vulnerability detections, and even for 0 days, which is really cool.
Yeah.
But I think we have to start wrapping up. I could talk to you about this stuff all day. I mean, there's 1,000 more topics I want to chat with, but there's only so much time in the world, and I want to respect your time too. So thank you so much, Adrian, for coming and joining with us.
My pleasure.
That was a really fun discussion.
Yeah, thank you so much.
You too.
Have a great evening.